Welcome back to Channel 9 Live here at Microsoft Ignite in Chicago. My name is Matt McSpirit, Technical Evangelist for all things data center. Now remember, as always, you can interact with us through Twitter at hashtag MSIgniteCH9. And also, if you prefer filling out the good old forms, you can get to us on channel9.msdn.com. Look for us under the video and tap away, give us your questions, and we'll try and answer as many of those as we can in the session. Now, I've been joined by Greg and Anand from our data center networking team. Thanks, guys, for coming along.
Hey, Matt. It's great to be here.
Good.
Hey, Matt.
By the way, congratulations on your book that you published earlier this year on
deploying Hyper-V with software-defined networking and storage.
Exactly.
Thanks.
Very relevant.
Thanks for the shameless plug, Greg. I
no
appreciate
problem.
it.
I
yes.
helped with it, so.
You did, yes. And you were credited in the book.
Oh, very good.
So thank you very much. Now, thank you for coming along. I've been monitoring Twitter and other social feeds for stuff around networking this week, and it seems like people are pretty excited about what's coming in the next release of the platform and in Azure Stack, and I know we're going to talk about that in more depth as we go forward. But before we do, bring us up to speed with just what we delivered in 2012 and 2012 R2 around networking. So bring people up to speed.
Yeah, so there's a lot in 2012 R2 around networking. That's one of the reasons why I wanted to mention the book, because it's already out there. People can use it today. We have customers deploying it in production. And customers today are taking our base platform, going beyond just basic VLANs and deploying the way they've traditionally been doing it. And they've been deploying and adding network virtualization on top and already deploying the software-defined networking concepts that we have in there.
Right.
So they can create virtual networks containing multiple subnets. We have a distributed router that runs in those virtual networks that sends the traffic between the subnets automatically. They deploy gateways. Windows Server has a very rich edge in the box today. So they can deploy these gateways and give these virtual networks connectivity to the rest of the world from within those networks.
And that was new in 2012 R2, the gateway.
Exactly.
Right.
I mean, we've had network virtualization since the 2012 release, and we've been building on it in 2012 R2. We're using it in the cloud platform system.
Yep.
So it's really been maturing over the last few years.
Okay, and all that's managed through VMM, System Center?
That's right. You deploy the edge, you deploy your infrastructure through System Center VMM, and then you configure it through VMM, build the logical networks and all the logical constructs through VMM and System Center, and then you can deploy as a tenant, either through System Center or through the Azure Pack.
Right.
The same UI, very similar to what you get in Azure today. You can deploy that through the Azure Pack as well, and then you can give tenants self-service access to their virtual networks.
Okay, so that's some of the stuff I can do with network virtualization, but why would I change from VLANs? What are the big kind of benefits of NetVirt? Well,
the nice thing about network virtualization is you can put it on top of the foundation of infrastructure that you already have, right? We don't take any dependencies on the physical network. So if you're using VLANs out there for your management, there are just a few things you have to do to create a VLAN, allocate some address space for the physical network, and then you make it very static, very reliable, and very robust at the physical layer. And then you can layer on top of that, anytime you need a new network for an application or a new network for a tenant, you can create that through software without touching that physical layer that runs underneath.
Right.
So you can do very dynamic creation of these networks, delete them, you can create dozens of them, you can clone them. All the operations you can do on a VM, you can then do on a network as well. So you can clone an application along with its network and get an exact copy. You can deploy a new version of the service into that network, and it'll get the same address space. And
so my workloads, even though we're using network virtualization to isolate instead of VLANs, I can still benefit from my workloads being isolated. I can benefit from the speed of deployment. I can do it through PowerShell as well, create these VM networks.
Absolutely. You do it through System Center PowerShell. System Center VMM has very simple commandlets. New SCVM network will create a new VM network. You want to add a subnet, it's a new SCVM subnet, and that'll create a new subnet.
Right.
So you do it all through System Center PowerShell, and it just creates it and pushes out all the necessary policy to the Hyper-V hosts that are needed then wherever a VM's located, so it knows how to communicate with the other VMs.
And as we said, you can learn more about it in the book as well.
Yes, exactly.
Yes, we went into extensive detail about deploying VM networks for a variety of scenarios, so yeah, check it out. Now, let's talk about what's coming next.
Okay.
Focus on what was in there already. People are up to speed now on network virtualization. We know it's powerful. It can be complex. We're adding more capabilities going forward, especially as we start to think about things like the Azure Stack, which we announced earlier in the week.
Yep.
Tell us how all this fits together.
Yeah, so let's look at these animations that I put together. So as I mentioned, you start with your basic physical infrastructure that you already have today. It's made up of compute hardware, top-of-rack switches, aggregate switches. These all make up your data center. You have load balancers in here as well, hardware appliances. Again, we don't want you to replace this. We don't want you to rip it out and have to buy all new stuff. But what we do is we layer through software a number of different services in different layers, starting with a lot of the core service that we already have in place today. So things like isolation through network virtualization, distributed routing, in there as well. Some of the services such as IPAM, DNS, DHCP, those exist today. They've been around for a long time and are very mature. Of course, we have a virtual switch that lets everything connect to, all your virtual machines connect to the rest of the physical network.
So it's all loaded within Windows Server?
Yep, this is all Windows Server and Hyper-V.
Right.
Some of these run Windows Server as VMs,
right,
like DNS, DHCP, and IPAM. Those tend to be separate VMs that run. But things like the switch, the network virtualization, distributed routing, that's part of Hyper-V. It's part of every Hyper-V host.
So before we move on, Anand, tell us a bit about what is IPAM for people that don't know, and DNS. Obviously, people will know what DNS is, but in terms of what's new in those particular areas.
Well, the main focus of IPAM has been to be able to go and organize your IP addresses in a very convenient way. So until the point we had IPAM, a lot of administrators would go and create spreadsheets to track all their DHCP IP addresses. With IPAM, it all gets very organized. You have a single view of every single subnet that you've allotted, where it's allotted, what's happening to it. And IPAM also gives you DHCP and DNS management. So IPAM was first introduced in 2012, where it does just IP management, and then in 2012 R2, we added a lot of capabilities to manage an actual DHCP server, and then we have carried that forward into vNext, where you can also manage some aspects of the DNS server.
Okay.
So it's a compact solution to manage all your addressing and naming infrastructure.
So when you say managing your IP addressing needs, is that purely at that physical layer, or can it be used when we get into the virtual layer as well?
Well, it started with the physical, and in 2012 R2 we did something great. What we did was we also added the capability to go and manage virtual addresses. So IPAM is capable of actually going and integrating with VMM, looking at all the address spaces that VMM has configured, read them into IPAM and manage them there.
So as an administrator, you get that central view across, okay, I've got these IPs allocated in virtual networks, network virtualization being used there, and I can see them side by side with all of my IP addresses that perhaps are running my management network and my, I guess, so also my user networks as well for my laptops, desktops, and everything. So a real centralized view.
Right.
So what about DNS? What's new there?
Well, from the DNS point of view, we just keep adding the DNS management into IPAM.
Right.
And we have built a lot of features in DNS that makes it deployable as a service in Azure. Those have been the main, those have been the main investments.
All right, cool, excellent. So what's the next layer that we've got?
All right, so the next layer, we've talked about the core services, the things that are really in Hyper-V and some of the things that run underneath. Now we add on another layer that we call network services. Again, these are split between Hyper-V and the platform, and some things that are provided by different VMs that run in the environment. So, for example, we now have a software load balancer. This is the same software load balancer technology that all of the viewers can use in Azure today.
Right.
That same software load balancer, we're moving it into the Windows Server platform, so now you can deploy that in your own private clouds, your own, if you're a service provider, you can deploy it out to your customers as well.
So this isn't just the regular NLB on steroids.
Right, it's a very different technology from NLB. NLB is very dependent on doing things with the MAC address at layer 2, doing broadcasts. This is a full software load balancing technology, layer 3, layer 4 load balancing, where you have a component called a MUX, where the traffic comes in, that's where your virtual IPs live, and then it makes the decision based on source and destination address. It'll do some hashing on that, source and destination port, protocol. It'll do hashing based on that and distribute it out to a number of VMs behind the scenes.
Right, okay, so this is a significantly different venture than NLB was.
Yep, absolutely.
And it's been battle tested, you said, in Azure.
It's running at hyperscale in Azure. Like I say, everybody can go out and use it today there.
Okay, and
same technology.
That's another good example of where Microsoft is really bringing its experience, its expertise, its innovation from the cloud and bringing Azure to your data center in the load balancer. So tell us about some of the others there.
Yep, so some of the other things that are new, a feature called service chaining. Service chaining is a way to bring virtual appliances, third-party virtual appliances, that you may use already on premises. You may want to bring that into a hosted environment or into your own private cloud environment, bring those same appliances into a private cloud, and then start to redirect traffic to these appliances. Do things like deep packet inspection, antivirus scanning, things that can intercept the traffic like a bump in the wire. You define rules similar to a 5-tuple firewall that will match in the virtual switch. The virtual switch will then encapsulate the packet, send it to the virtual appliance, where the virtual appliance can then process it like it normally would as if it were a physical appliance. Now you can do it as a VM in there.
Okay.
And so the same tools that you use for managing these third-party appliances physically, you can use for managing your virtual ones as well.
So give us a few more examples of some of the types of appliances we see. And also, are these Windows-based appliances? Can they be non-Microsoft-based appliances? Give us a bit more.
Yeah, absolutely. I mean, a lot of these appliances today are built using Linux, some are built using BSD, and we're doing a lot of work to make sure that Linux and BSD perform as well on Windows as Windows does. We want to make sure they perform as well on Hyper-V as they perform on other hypervisors. So we're doing a lot of work. We have a team that actually contributes to the Linux kernel, the Hyper-V integration components, and they're constantly doing performance improvements. Over the last year, they've bumped up the performance significantly for just VM to VM communication, and also for the type of forwarding traffic that an appliance like this, like these, would use.
Okay, so what kind of appliances?
Oh yeah, so things like antivirus, firewalls, any types of things like that.
Okay, well that's a good
packet inspection.
So what else have we got on there?
Yep. So we already have site-to-site. We already have VPN. We have forwarding gateways and NAT. Those are existing technologies that we've had in 2012 R2. So,
and they're built into Windows, those
Yep, exactly.
Yeah.
They are built in Windows Server. We recently added GRE tunneling to the gateway as well. So GRE tunneling, do you want to talk a little about that, Anand?
Yeah. So GRE tunneling is used in scenarios where you basically want to access something in your physical network in the cloud infrastructure from your tenant virtual networks in the cloud.
Okay.
So one use case for that would be, so far, until around 2012 R2 timeframe, you could only come into your virtual networks over a site-to-site connection. But starting in Windows Server vNext, you'd be able to come on high-speed links. So you could have MPLS links coming and terminating in the cloud, bringing all the tenant traffic. And there is a need to take the traffic from that edge MPLS router, wherever it's sitting, to your virtual network. And what you do there is you basically build GRE tunnels between this router that is sitting at the edge and your gateway, and you just tunnel all the traffic through the entire physical network to the gateway. The advantage of that is, prior to having the GRE solution, you had to go and use VLANs to achieve the same thing. You had to go and configure VLANs all along the path between the router and the gateway. So you don't have to do anything like that now. So it is it's a much better solution. It's much more manageable. It's scalable.
Yep.
It's a much easier solution.
Okay, and again, that's all built in as well?
Yes.
Okay, so that's our networking services layer. Is there anything else on there we need to think about? What about the firewall there?
Firewall, so basically firewall, we already have Hyper-V extended port ACLs today in 2012 R2, but firewall is the addition of these capabilities through our network controller, which I'll talk about as we get up a higher layer. You can deploy the firewall. It's a distributed firewall that gets enforced at the vSwitch level in Hyper-V. But you control it through the network controller. As the central point, you'll define your rules. And we're adding the ability to have different policy groups, so you can apply to these firewall rules to an entire subnet rather than an individual virtual machine, like you have to do today with the extended port ACLs.
Right, okay, so it seems like these network services, there's just a lot of stuff going on there in that layer. But before we move on, we've had a question from James, so thanks for getting in touch. Can the software load balancer that's included in the Azure stack run on Nano Server?
Not yet, but we are working on moving more of our roles to run on Nano Server over time.
Yep.
So
it's still early.
Yep, it's still early to decide that, but
okay.
At some point, I think that's a good possibility.
Okay, yeah, and it makes sense. It makes sense to add these, or give people the option to add these capabilities into Nano. Nano's proving very popular, as you'll see, and as you've heard at the conference. So, carry on.
All right, let's go up to the next layer.
Yep. This animation is impressive, I've got to say. There's some serious hours on this PowerPoint graphic.
A member of our team, Ben Schultz, I'll give him credit for doing all this animation. I don't know if he's watching right now, but good job, Ben. Anyway, one layer that we kind of skipped over early on is this foundational services layer. This is a lot of the technology that runs deep in Hyper-V, under the vSwitch layer even, that give us the ability to tunnel the network virtualization packets from Hyper-V host to Hyper-V host. Today we do it through NVGRE. In Windows Server 2016, we'll also add support for VXLAN as well.
That's a lot of acronyms. So what is NVGRE for people first?
So NVGRE is basically stands for Network Virtualization Generic Routing Encapsulation.
Right,
so
good one, yeah.
GRE is an existing technology. It's been around for a long time. It's used in VPNs.
It's not just a Microsoft thing,
no,
is it, GRE?
GRE is not a Microsoft thing. What we did years ago when network virtualization was in its infancy is we picked that as kind of the foundation for being able to encapsulate the virtualized packets as well. And we basically extended it by using what's called a key field in there that gives us a place where we can put the virtual subnet ID. We felt that at the time that would give us a lot of interoperability with existing devices. Over the years, we've seen VXLAN actually get a lot more momentum in the market and a lot more momentum in third-party devices. And so we're embracing that momentum, and we're adding that to Hyper-V as well.
Okay, VXLAN being an implementation that's used, again, standard in the industry, but it's used by people like companies like VMware and others as well.
Yep. Yeah, and they're actually what the two technologies do is actually very similar. From the software layer, the user layer, administrator layer, even programmer layer, you don't see a difference between the two of them. It's all kind of plumbing that happens beneath the scenes. To be honest, you wouldn't know which one is which unless you actually put a packet trace in place and actually look at the packets.
But up to now, for instance, if you had an environment where I had some Hyper-V hosts, I had some vSphere hosts, the two wouldn't talk natively if one was using VXLAN, one was talking NVGRE. There'd have to be some plumbing, like you said, to make that happen.
Yeah, and to be honest, they still won't talk to each other directly for a while. Where the key is for VXLAN is in third-party gateways. So when we have third-party appliances, we have some today with NVGRE. We have an F5 Big IP will work with NVGRE. A10 has a gateway as well. Iron Networks built appliances that run Windows Server on them. But this will open it up to additional physical switches that support VXLAN.
Okay.
And so through those switches, we can then interoperate with other systems that support VXLAN too.
Excellent. Okay, so that's NVGR. That's the encapsulation there. What's BGP all about?
Do you want to talk about BGP?
Yeah. So BGP is the routing protocol deployed in data centers. Basically, it provides the same advantage that any routing protocol provides. Prior to deploying any routing protocol, you had to statically configure routes so that two networks can talk to each other. They can say what one network supports, the other network says what it supports. Everything was static. You had to go and configure it on the routers. With the routing protocol, you can basically exchange all this information dynamically. And anytime the subnet is updated on one side, that is you add new subnets or you go and update a subnet, that information is also advertised. So that's what a basic routing protocol does. And BGP is one of the routing protocols. There are many, and BGP is one that is popularly deployed in data centers. So there's a lot of work that has happened in BGP. So we first added support for BGP in 2012 R2, and it is, of course, available natively in Windows. And in vNext, we have gone and added a lot of new capabilities to BGP. Like we have separated out the BGP control plane out and made a route reflector architecture out of it, so that anytime different tenants want to peer, they can just go and peer at one router. And then we have gone and made enhancements with respect to adding a lot of new RFC capabilities into BGP, like aggregation of routes, preventing flapping of routes by dampening them. A lot of good stuff there. And another major capabilities is transit routing. So today, when you have different organizations connecting to the cloud, suppose you have two organizational sites connecting to cloud over site to site, right? And they also are interconnected between them. If anytime one organization wanted to talk to the other, they would go over their direct link. But if the link failed, the two sites were down. But now with transit capability, you can route all the traffic between sites through the cloud. So all the traffic comes from one site to the cloud and then goes to the other side. So that's the transit routing capability which is enabled by BGP. So BGP provides you a lot of these cool things that routing can give you.
Nice. Okay. So I want to quickly go back to NVGRE and VXLAN for a sec. If I'm looking to embrace this kind of technology in my data center, you mentioned, keep things simple as possible in the data center, use what you've got. Are my switches going to support this?
Absolutely. The switches don't really care which encapsulation format you use. They just see them as packets with a source and destination IP, source and destination MAC. So they'll forward these packets to whatever their destination is, and they don't need to be aware of it. Okay.
Now, earlier on today, we had a session with Jose and Sid on storage. And one thing we talked about was RDMA. And I'm seeing that on your graphic there and thinking, are you stealing from the storage guys here? Is this a network?
I work with Jose a lot. We work together very closely between us and the storage team. RDMA, it's a technology that goes over Ethernet, so that's why we're deeply involved. Your regular network adapters generally now support RDMA if they're 10 gigabit or higher. But one of the key limitations in 2012 R2 of RDMA is that the RDMA traffic couldn't go over a virtual switch because the virtual adapter in the Hyper-V virtual switch didn't support RDMA technology. So what you had to do, or what you have to do today, is you have to have a separate pair of RDMA adapters that are separate from the adapters that are used for the VM traffic.
The
and that basically adds in more adapters into your host. Every host has to have them, more cabling in your racks, and more physical switches that you have to basically handle these additional adapters.
So to clarify there, if I had a host with two, normally I'd like to go as converged as possible, two 10 gig NICs, use Hyper-V host V switches to slice up some of the traffic isolation that perhaps I'm looking for, I would lose RDMA capability at that point.
Yep, exactly. So you can't send RDMA through the switch.
Right.
So the work we're doing in the next version of server is to make it so that that RDMA traffic can go in through the virtual switch and come out on a virtual adapter off into the parent partition of Hyper-V, so that now Hyper-V can now talk to the SMB servers, through RDMA, through the V switch, through that virtual adapter.
And is that exclusive to the host, or in theory, could it be through to a guest as well?
In theory, it could be to the guest. Right now, we're just showing it off going to the host, and that's really where the key is, because Hyper-V is the one that's storing those VHDs on the SMB server. It's also very valuable for live migration as well, because live migration using SMB as the transport also benefits from RDMA.
Yeah, and the impact on the server, as we saw when Jose did a little demonstration earlier on, is when you turn RDMA off, performance drops, the impact on the host CPU, the utilization, the resources, all gets impacted. So
did he show you the 100 gigabit transfer?
The 100 gigabit, yes.
That's impressive.
It was quite impressive. 11 gig a second transfer is a little bit slow, but you can deal with it. So talk us through Packet Direct.
Packet Direct is another one of these technologies that make the vSwitch more efficient. So today, when packets come into the Hyper-V host, they get processed by the network driver, right? There are a lot of interrupts that happen. Those interrupts are processed by the Hyper-V parent partition. Then the Hyper-V parent partition feeds it into the vSwitch, where it then gets shuffled around to all the VMs again. Packet Direct is a technology where those packets will go directly into the vSwitch, where they can get queued up there more efficiently and get sent to the VMs more directly. So one of the demonstrations I showed in a session earlier this week was a VM that was getting flooded with very small UDP packets. We were getting about 1.5 million packets per second getting to the VM from another source. When we turned on Packet Direct, we were able to double that throughput. We were able to get over 3 million packets per second going in there. And I don't know if there's another vSwitch on the market that can do that level of processing.
And is Packet Direct reliant on a specific type of hardware? Again, I mean, RDMA you mentioned is now more common on Ethernet NICs and also InfiniBand, iWarp, and so on. But is Packet Direct, has it got a requirement for certain hardware?
You have to have driver support from the network adapter, of course. You have to have it also for RDMA as well, going through the vSwitch. So there will be driver updates. There will be certain hardware that supports it. This week we've been showing primarily with Mellanox ConnectX Pro 3s. There will be more partners that will be showing off as we get closer to RTM.
So we've had another question in from Stanislav. Which of these SDN scenarios are available in TP2?
So we're really focusing the SDN scenarios on probably what will be coming after TP2. So you're not really going to see much. What you can do in TP2 is use all of the existing network virtualization technology. So you can build virtual networks. You can build, you can use Hyper-V extended port ACLs.
The gateways,
right? All the existing things in 2012 R2, you can use in the technical preview. So you'll see a lot of these other technologies come in, in
later
releases.
Okay. So that's the foundation. Is there anything else that we want to cover on there, like NIC teaming? Is there any changes there?
Nothing really new in NIC teaming that I would talk about right now. Same thing with quality of service. Nothing really I want to focus on. I want to use the time we have left to now talk a little bit more about the final layer on top. Actually, before we get there, we got a little more build out to do. I know. There's so much there. It's like there's a whole stack of Azure components that build up.
Who'd have thought?
And in fact, how appropriate. The Azure stack slide here basically shows all these Azure services now that you can run on top of the platform because we have them available down below. And of course, you have VMM that can still do the deployment, the orchestration, and management of the foundational layer, so that Azure has a whole team of developers that do their management. A lot of our customers don't, so they use System Center for that.
Right, that makes sense.
The last area I want to focus on, though, on here is the programmatic control. Because one thing that we only touched on a little bit is the new network controller that we have coming out.
I was going to ask about that. I've heard quite a few people talking about that based on sessions, and I was going to say, where is this controller coming in? Because it seems like it's a pretty powerful component of this entire solution you've got here.
So today we have a network controller. It's in System Center VMM. That is our network controller for 2012 R2. We're breaking that out into a separate service that will run on the network that will be resilient to failure, meaning if one node goes down, another one will immediately pick up the new traffic. And we're building in a lot of these additional technologies. We actually took the vast majority of this code from the controller that runs in Azure at Azure scale, and we're porting it into Windows as well, just like a lot of other things you've seen. And we're basically making it also have a very programmatic interface. We're making a REST-based interface where you send in JSON documents into the REST calls, and then the network controller will process those documents.
So you're saying there that similar to what we saw with the Azure Resource Manager and being able to create very granular but JSON-based templates that enable us to deploy. Network controller can help us with that as I think part of that?
Yeah, and absolutely. And that's the foundation of the Azure Stack UI that runs at the very top. If you look what we have today in the Azure Pack, the UI looks very similar, but that's where it ends, right? Underneath, it's different APIs that are getting called. And it's actually different code that runs underneath it. Today, in the future, when you get to 2016, it's the exact same UI code calling into these resource providers that are provided by these, that underneath call into the same REST APIs.
Right.
So it's the same code, the same APIs that are exposed by Azure are getting exposed by this network controller as well.
So what does it do?
So it basically, you pass in the commands to create the virtual network. The virtual network gets created. The controller then knows where all the VMs are, just like System Center does today. It knows where all the VMs are that need to have the rules needed to process the traffic. And it goes out and passes that traffic on to all the hosts out there.
Right.
It's the main interface that developers will use. We'll have third-party applications that are talking directly to our controller in addition to System Center. And we'll have a PowerShell layer as well so that administrators can use it as well and can talk to it. And
so let's just drill into it a little bit further, actually. In terms of, you mentioned it's a service that we're making available. Is it a role or feature of the operating system that I enable? Is it something that, you mentioned high availability, so I'm guessing is it a clusterable component? Or explain a bit more about from an architectural perspective, what people expect when it comes to deployment.
So the network controller will run in a virtual machine. It will run, if you want it to be highly available, you need to have 3 of them deployed out there so that you can survive a number
all
of
on the same host, right?
No. If you like it all to fail at once, yes, then all on the same host.
Not saying it would fail. That
not a best practice. I'll just
check out the book, because we don't do that in the book.
And within these 3 VMs, there's a technology called WinFabric that basically acts as a cluster that decides which one of these nodes is going to be active at a time. Running within each of these now are a number of managers. There's a software load balancer manager. There's a virtual network manager. What are some of the other managers that we have running?
We have one for the gateway itself.
All right.
And then there is one that goes and does the monitoring of the physical network. And then there is one that does the discovery of the network in the case of CPS. And it is also able to go and configure the logical network, etc. So every network function that you want to perform has a service manager or a service module inside the network controller,
all within
where the business intelligence resides.
Okay, so as an administrator, will I go into Windows Server and bring up the network controller view, and I'll have all of these things in a nice dashboard, or is it likely to present itself through System Center going forward? Obviously, you can't speak specifically.
You'll deploy through System Center. You'll create your SLB muxes. You'll create your controllers through System Center. You can deploy them outside of System Center if you want, but System Center makes it easy.
Right.
Easier. It may be easy by the time we get to 2016.
Well, read the book.
There's still a year to go. So that'll do your basic fabric configuration. It also deploys the Hyper-V host, gets the vSwitch set up. But the main way that we expect, again, tenants and the actual workloads to get created is through the Azure Stack. So the same UI that you get in Azure, that you can use in Azure today, you can try out their preview, you'll have available to your own clouds that you deploy with the Server 2016 as well.
Right.
So that's how tenants will interact with this. So they get all that same UI.
Yeah. So it's not the network controller. I'm guessing is not something you would ever really expose to tenants per se.
No, tenants would never see it. Even administrators won't interact with it directly that often. It's really something you would do through VMM, through other applications. Developers, we want developers to write to it. We want developers to use our REST API. We want partners to use it.
That was going to be my next question. Actually, is it going to be extensible for partners to plug in directly? So I can see, okay, I've got a view of the services you mentioned, but also service X from such a...
Yeah, we definitely want partners to be able to query into the controller to pull information out. We also want them to then push policy into the controller as well. So if you're a partner out there watching, talk to us, and we want you to get involved in early on start programming against.
And Greg's email is Greg. No.
Yeah.
Thanks. Move on. No, okay, well, we're starting to get to the end now. Before we wrap up, you'll be on the booth, so people can come and chat, I guess, for the rest of today at least. What other sessions have you done this week, or are you doing still that people could check out on demand?
Yep, we had a foundation session on Tuesday in the morning where we talked just about networking. We co-presented with Azure.
Yep.
We went through this in much more detail. Actually did a lot of demonstrations. We had a session, Anand and I had co-presented a session yesterday.
Yeah, we had a session on all the edge services.
Yep.
So we covered 2012 R2 and all the network services that we introduced there, and then we moved from there to vNext and spoke about SLB, firewall, service chaining, and all that.
Cool.
So the entire session is about that. Yeah, it's a good session.
And then right after this, if you're still around, I have a session on CPS networking, cloud platform system.
It's a shameless plug, Greg. There you go. So we've got to wrap up. That's all we got time for. Thank you very much for joining us. Thanks to the guys. Up next is Joey and Rick on Patch and Switch. See you again.